Okay, so in each of these, we're going to find the derivative of the following functions. We're going to create a formula or use the value. And then we're going to find the equation of the tangent line off of that derivative. So remember, the derivative is the slope of the tangent, and so we can use the slope and a point to create the tangent line. So let's first find our point. So if I were to plug in 4, I would get 3 times 4 minus 4, and so that's 12 minus 4 is 8. So it's the point 4, 8. And so now we're going to use the limit of the distance quotient. So it's the limit as h approaches 0 of f of x plus h minus f of x all over h, and this will be the slope of our tangent. Okay, so first thing we need to do is find our f of x plus h, and you notice our x here is already 4. So this becomes the limit as h approaches 0, f of 4 plus h minus f of 4 all over h. So the first thing we need to now do is find f of 4 plus h. So we do f of 4 plus h. So that would be 3 times 4 plus h minus 4, which gives us 8 plus 3h. And then we move on to the next part, which is our f of 4. And so all we're doing is really just finding the numerator for our slope, and then we'll find the denominator of our slope, find the slope of our secant, take the limit as h approaches 0, and there we go. So we're going to take these now and subtract them. So what is f of 4? So f of 4 is 8. So this becomes 8 plus 3h minus 8. And all that's really happening is whatever is here, you're just going to cancel that number. So that 8 and that 8 cancel, just like this. So we can take this and make it a lot quicker just by writing what's left. And then we divide it by h, and we end up with 3. So the last part now, because this is the slope of our secant here, is to take the limit. So if we take the limit as h approaches 0 of 3, we end up with 3. So this is the slope of the tangent. So that's all you're doing. You're taking the difference quotient to find the slope of the secant, plugging in the limit as h approaches 0, which gives us the slope of our tangent. Let me make that a little larger here. Slope of tangent, that's better, is 3. So that's the first part. That's part A. Part A is 3. Part B, now we want to find the equation of the line. So you're going to take that slope of 3, that point that we found, 4, 8, because what we're doing here is this. So we first found the slope of our secant, and that was 3. And then we took the limit as h approaches 0, which gave us our derivative. And so now what we're doing is taking that point, 4, 8, and the slope to get the equation of the line. And so we take our y2 minus y1 equals m, x2 minus x1. Take off the 2 because it's not a slope here. And then we plug it in. So y minus 8 equals 3x minus 4. And this is a perfectly valid equation of a line, but we're still going to finish it into slope-intercept. So y equals 3x minus 4. Look familiar? Yeah, we started with the line. So of course the slope of the tangent would be the line itself. So you can see it already is the line y equals 3x minus 4, but I just wanted to use that one as an example because it's a very quick example. So again, here's the process. We find 2 points, right? H units away. That gives us the secant line. We then have h approach 0, which then gives us the slope of the tangent, and then we get our line. Let's try a polynomial here, our quadratic, our parabola. So again, first thing you want to do is find that first point. So our x here is 5. So we plug it in because we want to know what the y coordinate is. And so that equals -1. So our point that we're going through is 5, -1. So our graph looks like this. We have our parabola. Our first point that we're trying to find is at 5, -1. And then again, we're going to find the slope of that secant. And then take h as it approaches 0. which gives us our slope of our derivative. And then we will find the equation of this line that is created as the tangent. So the slope of our secant now is where we're going to start. And so that would be f of x plus h minus f of x, this is our formula, over h. And then we plug in our x, so 5 plus h minus f of 5 over h. And so we're going to find the f of 5 plus h, and then subtract the f of 5, which we know is -1, from it, and then divide the whole thing by h. So let's try this. So f of 5 plus h, that would be 5 plus h squared minus 4 times 5 plus h minus 6. And that's 25 plus 10h plus h squared minus 20 minus 4h minus 6. And then knowing these are right, we're supposed to be getting f of 5 is -1. That's going to be canceling with these constants. So everything should come out to be -1 if we did this correctly. So 25 minus 26 is -1. That's perfect. So we end up with, we'll put the -1 first because we're going to cancel it anyways. -1 plus, and then it's 10h and 4h, which is 6h, plus h squared. So let's double check this. We have h squared. Check. The 10h and the 4h makes 6h, and then 25, take away 20, take away 6 is -1. Okay, so now we do f of 5 plus h minus f of 5, and all that means is to take that -1 and cancel it with that -1, because that's our f of 5. So we end up with 6h plus h squared. Now if we divide everything by h, it cancels off an h, giving us 6 plus h, and that's the slope of our secant. Okay, now we're going to do the slope of tangent, and so that's just the limit as h approaches 0 of 6 plus h, and it's always quick. You just say, oh, you're 0, and you move on. So the slope is 6. Okay, so that is part A. All I'm going to do now, shrink this to give me a little more space. I have to make it large for your viewing pleasure. But now we can move it over, just like that. Draw our line. And so part A, the slope of our tangent, which is our derivative, is 6. So f prime of 5 is equal to 6. Remember, the prime notation on your function means derivative. So f of 5 is -1. F prime of 5, which is our derivative, is 6. So now we need to just find our line. So we take our slope of 6, 5 comma -1, and we find our slope. So our equation. So y minus -1 equals 6x minus 5. So that's y plus 1. 6x minus 30 minus 1 minus 1. 6x minus 31. And so that should be the equation of our line. And so we go back to Desmos, and you can see that was our tangent. And so if I plug that right in, you see it overlaps perfectly. Comes back here at 31. That was our y-intercept. So that is the slope of our line, which is 6. And the equation of that line is 6x minus 31. So again, you find the point. You plug the point in. And then with this, and then you figure out what this is. This is the slope of our secant, and so we end up with 6 plus h. So like this. Let's click this guy off. Click off the derivative like that, and then we have h approach 0 with the limit, which gives us our tangent. So we found our secant. H units away, limit as h approaches 0, we get 6. All right, the last one is our rational function. I need to show you how to do those as well. And then the next video after this will show you rationalize the denominator with radicals. So we're going to first again find out what f of 7 is. So 7 over 7 plus 2, that's 7/9. So we end up with 7 comma 7/9. That's our point. And then again, we're going to find the slope of the secant, and then end up with the limit as h approaches 0 of the slope of our secant, whatever we get. So this is f of x plus h minus f of x all over h. And again, we plug in our x, so f of 7 plus h minus f of 7 all over h. And now you can use the formula as well, f of x plus h, and do all the work we've done before, and then plug in 7 at the end. It's your option. It doesn't matter if you plug 7 at the beginning or at the end, it'll work out the same way. Okay, so f of 7 plus h is what we need to find first. So let's come down over here and put f of 7 plus h, and we plug it in. So 7 plus h over 7 plus h plus 2. And this becomes 7 plus h over 9 plus h. Now, here's the difference, is when you plug these in, this is why we're doing a rational, and then our f of 7, that's the second one here, is 7/9. We plug them in. You see that they don't cancel right away. They're going to, because we have to. We need to make sure this h cancels. That's the goal on every single one. You have a denominator of h, and if that were 0, we're getting undefined. Denominator of h. And so by simplifying the top, they're giving you an h to cancel. And so here we're going to simplify the top, and the h will cancel. So here's the trick. You're going to multiply the top and the bottom by our denominators, which are 9 and 9 plus h. So 9 plus h, 9 plus h, and then you also have to do the denominator. So I'm just multiplying every term, multiplying the entire top by 9 plus h, and the bottom by 9 plus h. And you end up with the 9 plus h cancels. We'll put that in green, cancel, and you end up with 7 plus h minus, and then the 9 cancels, and you end up with 9 plus h all over, and then we leave the bottom alone. Don't touch it, just leave it alone. Okay, now we just keep simplifying here. So this would be 63 plus 9h minus 63, see, there's the two numbers, minus 7h, and so there's some canceling that'll go on. That's what we wanted. And then again, leave the bottom alone. If you can put 9h if you want, 9 plus h, that's fine. And then on the top we end up with 2h, and we'll just shrink all of this when it's done. 2h over 9h, 9 plus h, and you can see now that the h's are sitting there all together, and you can cancel. And so we end up with 2 over 9. Why is it still in red? I don't know. 2 over 9, 9 plus h, and that is the slope of our secant. Once you cancel that h right here, you're done. Done with the secant. Okay? Okay, let me shrink all of this, fit it in here. Okay. So, we found the slope of the secant, 7 plus h. Rewrite it here. Multiply everything by our denominators, 9 and 9 plus h. They cancel. And then we do some distributing, and then those will cancel, leaving us with just h, and the h will cancel. So this will work every single time with rationals. Okay, now that we have the slope of the secant, we can now move on to the slope of our tangent. So the slope of our tangent is going to be the limit as h approaches 0 of the slope of our secant. That is our f of x plus h minus f of x. So we go limit as h approaches 0, 2 over 9 plus h. And you can see now this h is not just a plain old denominator. See, like if I were to go like this, that would not be good because it would be undefined. So you have to do all this work. All right, and then this becomes 2 over 9 times 9, because that's just 9 times 0. Okay, so it becomes 2 over 81, and that is part A. That is our derivative. So this is our f prime, and our number we plugged in was 7. So f prime of 7. Okay, now we need the equation of the line, so you just take that 7 comma 7/9. You take your slope of 2 over 81 and you plug it in. So y minus 7/9 equals 2 over 81, x minus 7, and you say, I'm done. I don't want to deal with this. It's a good enough line. And then again, we found the secant. Obviously, this is just an h of 1. What we found is an h of anything you want it to be. And then we took the limit as h approaches 0, which gives us our derivative, which matches our equation perfectly. So there you have it. So that's your steps. Number 1, you're finding the slope of the secant using our difference quotient. Number 2, you're taking the limit as h approaches 0 to find the instantaneous or the derivative or the slope of your tangent, any of those words that they're using. And then you're plugging it in to find the equation. Thank you.